Hello guys, welcome to the next lecture on the PY question series. Today I will explain you the topic of normed linear space from the functional analysis. Myself Dr. Harish Garg. You can simply follow my YouTube channel where you can find the PY question playlist of the GATE mathematics, and you can see the various PY questions from the last 12 to 13 years. You can easily see in these lectures. You can see from the fixed point, power series, ordinary differential, numerical, Bessel's, and many more available in this complete playlist. If you watch it completely, I am sure that you will qualify your examination in a simple manner. So let's me quickly explain you what are the various shortcut tricks and how you can approach towards the examination within the 10 to 15 second time period. So first of all, what is a normed linear space? A normed linear space, first of all, is a vector space. So you all know vector space has several properties. You must understand this. And additional property is a norm is defined mathematically. If V is my any real or complex space and this is my norm, then the ordered pair is called as normed vector space. Once you can define the norm, what is the properties of the norm? You all know these are the four basic properties for the norm. For example, if I call this is a L, this is a 2 norm, we also call as the L2. This is my 1 norm, this is called as the L1. This is my infinity norm, it is denoted like of this, and this is my LP norm. You must understand, you must remember these formulas for the whenever you are approaching toward the functional analysis. If you are working on the matrix theory, then the norms is defined like here. This is a root of trace. TR is called as the trace of the matrix. It's a sum absolute and the maximum absolute values from here. If you are working on the operator, then the norm is defined like here. Maximum of AX provided norm of X is less than 1. Once you can define the norm linear space, then every norm linear space is a matrix space. When you call as a matrix space, you must have a one matrix, and that matrix is my X minus Y, norm of X minus Y. For example here, so if you consider X is my R of N or C of N, then this is my L2 norm. You can simply say it's a L2 norm. This is the LP norm, and this is my norm of infinity. If on the other hand, this is, remember that this is for the discrete case because I have written as a summation. If you have a continuous function, then instead of taken as a maximum, you can define as a supremum of this function. And this concept is very, very important when you are thinking about the norm of the function. Make sure whenever you want to find the bounded linear operator, you can define, you must satisfy this property, then the function is or the operator is bounded. Or if you want to prove norm of Tx is less than of the M, only if you consider X whose norm is my 1, then you can simply say norm of T is less than of the M, then again it is called as the bounded operator provided norm of X is my 1. Again in this case you can define this is also like norm of F is supremum of F of T divided by norm of F. If norm of F is my 1, then the simple case is here, otherwise you can define like this manner. As I told you here, the norm is defined like supremum of Tx divided by norm of T. That's a simple way you can define. Another remark for you, if you have the two different norms, both are on the equivalent provided your space is my finite dimension. And if you define the finite dimension space which is always complete, and any finite dimension norm linear space is always closed. The last concept is you always utilize this Rees representation theorem is a very, very important. Whenever you want to find norm of the function f, then if you write written in the form of the inner product space, then norm of f is same as norm of y, and also it has a unique y. Lastly, you can simply understand the difference between the small LP and the capital LP norm. Small LP is defined like here, capital LP is defined on this continuous this one. So based on these simple shortcut tricks, I can solve all those PY questions within the 10 to 15 second time period. I hope you can comment and the like on the video as well. You can join with me through my WhatsApp group. You can scan and join here. So let's start with this one. The first tip for you. First of all, you have to look about what you want to find. Your target is to find the norm of this. Whenever your target is to find the norm of phi, and look at the phi is my here. Can you define this in terms of the inner product? It is my f. You can write it as a f. What is the remaining thing is? F is already written. What is the remaining is my 3 root 2. Then this is norm of 3 root 2 by using Harish representation theorem. Fine. Now the question arises is, what is the norm of this? Is it a maximum norm, L1 norm, L2 norm? Look at that. F is defined on the L2. If I call as a LP, then this is defined on the LQ, where P plus 1 over P plus 1 over Q is my 1. So if I compare, P is my 2, can I substitute here? What is my Q? Q is my 2. So what is the definition of the norm 2? What is the definition of this norm 2 over the continuous product? So that is the integration from the domain 1 by 4, 3 by 4 of this square into dx raised to power 1 over 2. That's it. Whatever the answer, that is my required answer. Now you can see it's a 9 to 18. Integration of the 18 is my 3 by 4 minus 1 by 4 raised to power half. So it will be my 1 over 2. It's a 9. 9 of root is my 3 is the right answer of this problem. Always remember my shortcut tricks like here. Look at this another one. Again, your target is to find the norm of t. So I can written this as f into something. Now it has a 2 component. I call this is my say g, where g is defined as when the domain is from 0 to 2. The function f, corresponding f is my 1, and whenever it's from 3 to 10, the domain is my, I written as a plus here, it is my minus 1. So it is my minus 1. So what is the norm of t? It is norm on g by the Harish representation theorem. So again it is on the p. P is my 2. So q is also my 2 by using 1 over p plus 1 over q is, so it is defined on the 2, and in this case norm is defined like here. So I can apply this definition. So it is from 0 to 2 plus 3 to 10. So what is that? F is like g, so it is a 1 square into dx, and it is minus 1 square into dx, and it is my power half. So what is the answer? It's a 2. It is of here. So 7 plus 2, 9. 9 of root is 3 is my required. Only remember this shortcut trick, you can solve any of the norm in a simple manner. Again you can see your target is to find the norm of t. So I can write this function is, the function is defined on the f. So f comma g. So what is my g in this case? Again there are the 2 cases, minus 1 to 0, the value is my 1, and from 0 to plus 1, the value is my minus 1. So by the definition of the Harish representation theorem, it is the norm of g. What is that? The norm of the g, it is a C continuous mapping defined on the supremum. So this is on this. So what is that? Supremum of the mode ft. What is the mode of ft is this, plus, because it's a discrete, so I can written as a summation sign. So 1 plus 1 is 2 is my right answer of this problem. You can see maximum of the 10 to 15 seconds you are needed to solve this problem, and that much second you are needed to comment and the like on my video. Okay, look at this again. You can see your target is to find the norm of t, and I can written this is, it is defined on the f comma, what is the second part is 2x. So it is a norm of 2x. What is the condition of this is infinite. So that means it's an infinity of this. So how you can find that? Again very simple. I can simply, domain is my 0 to 1. So what is the answer of this? It is my x square from 0 to 1, it is my 1. So the answer is simple 1 is my right answer. Or there is one more method. Second method is, since my target is to find the norm of t, I can simply take f is my 1 because f belongs to my continuous function. So I can take f is my 1. So what is my t? T is simply 0 to 2x. Then norm of t divided by norm of f is 1. It is again 1. But always remember this shortcut tricks for you. Okay, look at this one. Your target is to find of this. If you remember, what is the definition of this quantity? This quantity is nothing but my norm of the g of whole square. Fine. Is it clear? Now, what is the g? If you look about that, g of x is summation of xn divided by 3 raised to power n. Now, I can return, how you can define by the Harish representation theorem, I can return this quantity. Firstly, I can return this quantity as this. It is defined on the x. So I can return here is x. What is the remaining component is 1 over 3n. So it means this value is same as of norm of 3n square, because I written square, it is a square. Now it means it is 1 over 9 raised to power n. So what is the definition of the norm? It is on the 2. Fine. Again it's a LP. So P is my 2, Q is again 2. So it is my on the 2. So I can define by using here summation of 1 over 9 raised to power n. Fine. Because already I taken as a square. So this raised to power 1 over 2. Fine. Because I already taken as a square. Otherwise you can simply consider like here. Then what is the definition of this component? I can compare this here. Xi is my inside component. So it will be my square of this square, that is a 9n. Fine. From 1 to infinity. So what is that? This is a GP series. So what is the sum of the GP series? A 1 over this. So it is 1 over 8. So I can substitute here. Norm of g square is my 1 over 8 is my right answer, because this is nothing but norm of g square. I can take 1 over 2 here on this side. So the answer is 1 over 8. Okay, again your target is to find the norm of f. Can you express this quantity in terms of here? It is on the x. The first value is my x. Second value is, what is the apart from the axis of this quantity? So what is the meaning of that? This value is nothing but norm of 1 over 2 raised to power this value. So what is the domain is? L2 on the R. So what is that? It is on the discrete case. So I can return this value is xi square of 1 over 2. So what is that? Xi square. What is the square of this? 1 over 2n from this value. Value is, domain is 1, 2. So what is that? This is again a GP series. So the sum of the GP is 1 over a over 1 minus r. So a is my this, r is my here raised to power half. So it is 1 of this. So the answer is 1 is my right answer of this problem. You can see maximum 10 to 15 seconds you are needed to solve the problem. Okay, look at this another one. Your target is to find the operator norm. Now it's a matrix. Fine. So then it means you are unable to write this in form of inner product. So what is the norm of T? It's a square root of trace of the A transpose into A. So I can found the A transpose into A if I call this is my matrix. So what is the A transpose? 1 1 3 2 2 2 1 3 minus 3 into A 1 1 3 2 2 2 1 3 minus 3. Now since my target is to find the trace, it means I need to find only the diagonal entries. So look at the first diagonal entries. So 1 plus 4 plus 1, 6. Second is second row, second column. 1 plus 4 plus 9, 14. Third row, third column. So it's a 9 plus 4 plus 9. So 18 and 22. So what is the trace of this? So the trace will be, it's a 20, it's 42. I can substitute here. It is root 42 is my right answer of this problem. Look at this another one. The norm of the functional f defined by here is this. Means your target is to define norm of the f. I can return this function again. First function is my x. So x comma g. Fine. So what is my g? It again break into the two component, -1 to 0. The coefficient of the x, coefficient of x is my 1, and from another is 0 to 1, coefficient of the x is -1. So it means this, by the Rees representation theorem, it is norm of the g. What is the domain? Norm is defined as maximum of mod t. So what is the norm of g? Maximum of this. So 1 plus maximum of this. So 1 plus 1 is 2 is my right answer of this problem. Remember that. For example, what is the meaning of this maximum? Say g is my t square and here is my 1 plus t, for example. Then how you can find it? Say this one, means if instead of this is my say t square and it is my say plus 1 plus t, coefficient of x, then find the maximum of t square over the domain -1 to 0 plus find the maximum of 1 plus t. Fine. If I written as a small t, then it is my t. Then clearly say what is the maximum of this. The maximum over this interval is my 2 absolute value, and what is the maximum value of this on this interval is 1. So the right answer of this corresponding to this change example is 1 plus 2, because here is only one constant value, so that's why I have written like here. Okay, consider the Banach space C 0, 1 on the supremum norm. Fine. Then the norm of the linear function L. So your target is to define this value. Can you write this L? It is defined on the f. So the first number is f. What is the another one is? Coefficient of the f is sine square x. So it means it should be the norm of sine square x, and it is a supremum norm. Fine. So what is the norm of the supremum? Norm of the supremum is supremum of this sine square x over the range. What is the range is 0 to pi. So can you find the supremum value of the sine square? So sine square supremum is always 1. So the right answer of norm of L is same as that of the norm of sine square x over the supremum. It is my 1. So the right answer is A is my right answer. You can see within the 10 seconds you can solve this problem very well. Okay, look at this another one. It's a recent year GATE examination. Again your target is to find the norm of f. So where is the capital F? Capital F is my here. So can I define this capital F? It is defined on this small f. So first function is f. What is the coefficient of the f is x square. Fine. So it means the norm of capital F should be the norm of the x square. So which norm? It is defined on the 2. So it means P is my 2. So again I can find the value of the Q. So from here I can see Q is my 2. So this norm is defined on the L, on the L2. So what is the norm of this? It is given here. Fine. It is defined like here. So what is the answer of this side? It is -1 to 1 mod of x square. So it is x raised to power 4 into dx raised to power half. So what is the answer of this? It is my 2 over 5 raised to power 1 over 2. Now your target is to find this norm of f square. F square is my 2 over 5. So what is the norm of 5x square is my 2 is the required answer. How many seconds you are needed? Whatever the problem is there, whatever the problem, don't bother about it. Look at the function and write my approach. You will get your answer in each case. Kindly like and share my video as well. Okay, so look at this function again. T is bounded or not? How you can prove the bounded? If I found that this should be less than of m, then it is bounded. Again, you can see your target is to find the norm of f. How I can return this function is, this is my x, fine. So I can return as a x. What is the other part is? It's a 1 over 1 square. It means 1 over n square, fine. So I can define this is tx is my norm of x comma 1 over x square. So what does it means? Norm of t should be norm of 1 over x square. So what is the domain? What is the norm is? Supremum norm, fine. So can you find this answer of this? It is my supremum of 1 over n square. And what is the n is? Many non-zero terms. So n is my natural number. So can you find the supremum of this? Supremum is 1, as n is a natural number. So clearly say when n is equal to 1, it is a 1. Rest all the terms are here. So what is our right answer? Norm of t is my 1, which is less than of some finite quantity. What does it means? T is my bounded, fine. So t is my bounded. So second option cancel, this option cancel, fine. Now if in this question they are asked you find the norm of t like in the previous examples, then the right answer is my 1. Okay, fine. Now what is the second component is? T inverse. Can you define the T inverse from here? Again, it's a very simple. What is the T inverse of x? So first component is x. What is the inverse component? Inverse component is defined on this. So what is the inverse is? N square. So what does it means? Norm of T inverse is same as norm of n square. And again, how you can define this? Again, the supremum norm is my this. So supremum n belongs to my capital N of n square. So what is the norm? What is the supremum of the n square? It is not exist, fine. So what does it mean? It means norm of T inverse does not exist, fine. So it means it is my unbounded. So T inverse is my unbounded. Both are bounded, the wrong option. A is my right. All of you know that it's a divergent sequence, fine. Or you can say it's a divergent are there. So it means supremum does not exist. So once the supremum does not exist, it is not. So norm is does not exist means it's a unbounded. Okay, look at this another one. Again, your target is to find the norm of t. So can I write, if I return this function is my x, then can I say this x into something? How you define that? First of all, it is start from the 1. It is start from the 2, 3, 4, and it is not, you can't write this function in this form, fine. Now how you can think about that? If I write, okay, again there is no worry. Look at the option bounded norm of t. Look at any value in between them. Choose any x L2. What is the meaning of the L2 is? Xi square, summation of the xi square should be finite, fine. You may choose like 1, 2, 3, and here last number is my say 4. So clearly say the square of this is a finite. But look at that, my first number is x2. If I choose this number 0, 1, 0, rest all numbers are my 0. Is it, you can clearly say 0 square plus 1 square plus 0 square is finite. So it means this part belongs to my L2. If this part belongs to the L2, what is my T of x? T of x will be x2, that is a 1. 1 minus 0, 1. 0 minus 1, it's a minus 1. 0, and rest of the next term will be x4 minus x3, 0, 0, and here, fine. Now again it belongs to my L2. What is my norm of this? So it is under root of, sorry, yes, it is a because it's a finite, it's a L2, so it's a 1 2. So 1 square plus 1 square plus 0 square plus 0, that means root. So it means norm of t should be my norm of 2. Why? Because you can see norm of x is my 1. Fine, 1 square 1 square. So I can define the norm of t is norm of tx divided by norm of x. So it is my root 2 divided by 1. So root 2, it is 1. Norm of 2 is greater than root 2, but it is a 1 point, it's a cancel out. It lies between, is it unbounded or this? Now you have to check about the bounded, whether it's unbounded or not. I think again a very simple, how you can check about the bounded? It means your target is to prove this number should be less than of this, like as I told you here. Fine, but in that case you are easily find the value of the g, but here you are unable. Again a very easy, you can see about that, x2 minus x1, x3 minus x1. So I can return this number is xn plus 1 minus xn. Fine. Now if I define this on the L2, if I start from the 1 to infinity, then what is my this case? On the L2, it is my under root of summation xn plus 1 minus xn square. Fine, by the definition of this, or I can return this number is of square, I can cancel it, and this value is less than of norm of xn plus 1 square plus norm of xn square. Why? Obvious that this number should be less than of a square plus b square. Fine. So this number is because it's a infinite, so I can say it's a norm of xn plus norm of xn. Fine. So it is less than of 2 of xn. So clearly say this is my m, which is a finite, so hence it is my bounded. So once t is my bounded, so this option is cancelled, only option is my here, and you can see whatever the norm of t for the one particular example I have computed is also satisfied. Look at this another one. Okay, again your target is to find the norm of t. Fine. How you can define the norm of t? Can you write this function? First one is f. Fine. And what is the coefficient of the f is e raised to power minus y. But make sure it is a x, so you have to write this as a function of the x. So how you can write that? So firstly, if you look about this function c01 t, so it means f belongs to my 0, 1. Fine. I can choose any function which lies here. The easiest one is f is my 1. Fine. So then what is the definition of this? T of x is x to infinity e raised to power minus y dy. Fine. I can simplify this. What is the integration of this? 1 minus e raised to power minus x. Clear? Then norm is my supremum. So what is the norm of tx? It is supremum of 1 minus e raised to power minus x. Fine. And the domain is 0, 1. X belongs to 0, 1. So what is the supremum of this? 1 is 1, it is my 1, so e raised to power minus 1. So what is that? Norm of t is my 1 minus y. Again remember that it is my supremum of tx divided by norm of x, and the norm of x is my, you can see over the 0, 1 is my 1. So clearly say 1 minus e is always less than 1, but he said 1. So what does it mean? Norm of t is less than 1. So once this is my less than 1, look at the second option, I minus of norm t, that is a 1 minus norm of t, which is a non-zero. Fine. If it is non-zero, what does it mean? It means it is my invertible. So once this is invertible, but he said not invertible. Fine. Now what you got, that this is my not invertible. So once this is my not invertible, what does it mean? T is my not onto. Fine. So it means this option is also cancelled. Only left option is my D is the correct answer. We all know, remember, if I say T is my not invertible, for example, you know what is the meaning of that? That means kernel of the T should be greater than 0. So by the rank nullity theorem, what is the dimension of the range space? It should be less than of the n. So once the dimension of the range space is less than 1, what does it mean? T is my not onto. Fine. The same concept I have used here. So it means T is my not onto. So last option is appending, which is the right answer. But if you want to verify it, the last option, how it is true, again very simple. If you look about the value of this norm of T, I computed as norm of T, I have computed like this manner. So what is the right hand side? Right hand side is 1 plus norm of T. It is 2 minus 1 over T. Now look at the left hand side. It is defined on this 1 plus T. So firstly, I have taken f is 1. So my Tx is here. Clear? So if I use the 1 plus T over the x, so it is my, it's a single. Firstly I can define over the f, then I can take f as a 1. So I plus T over the fx, so it is f plus T of f. Fine. So it is f of x plus T of fx. So fx I have taken as a 1. So it is 1 plus T of fx. What is the T of fx? This value I have computed as 1 minus e raised to power x. So it is 2 minus e raised to power minus x. I can define over the supremum norm. What is the supremum norm of this when x belongs to the 0, 1? Again it is e raised to power minus 1. Both are my same, so that the right answer is my D is the correct answer. Okay, look at this another one. Again you have to define norm. Again your targets to Tn. Firstly, it means you can write this in terms of x. Fine. If I define like here, then you can easily define this. I think it's a very simple. If I define this is my x. Okay, firstly you can choose n is my 1. Then it could be easy for you. You can think about this. Then T of 1 of x1, x2 and so on. It will be when n is my 1, n is my 1. So y1, j is equal to 1. So j is equal to 1 satisfied here. It is my x1. y2, j is equal to 2. When j is equal to 2, 2 is my greater than 1. It is xn. n is my 1. It is x1, x1 and x1. Fine. So what does it mean? If I choose for in general n, so j is equal to n, whenever x1 is less than of this, so it is x1, second is x2, up to the xn it is fine, and then rest is xn, xn, xn. Fine. There is no worry about this one. Now, how you can think about this other part? Norm of T. Can you return this is my x, but this is not my x? So you are unable to define like here. Fine. Then how you can define this? Norm of, then you can define like of this. What is that? What is that norm is? Infinity. What is the meaning of the norm infinity? You can take it as the supremum. This is my supremum of mod of this. If I define norm of this, so what is that? It will be supremum of this value. So supremum of this is my any of the xi divided by here. So what is that? This is the same of this supremum of xi. So it is basically a norm of T. So what does it mean? this is my Tn, sorry, norm of Tn will converges to norm of T as n approaches infinity. So it means, but he said does not converges, first option is cancelled. You can also see instead of this you can think about the n is equal to 1. Fine. So what is my T1 of x? When n is 1, so it will be x1 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 x1. So that means I can written as 1 1 1 1. Now you can see it is written as x comma 1 1 1 here. So then what is my norm of T1? That is a infimum norm. What is that? Supremum of mod of 1 and so on. What is that? Is 1. Then you can define the T of x. Fine. It is again, because each of the xi's are my, again I can return this number is x comma 1 1 1. Then only the dot product will be here. So again the supremum will be my 1. Both are same. It means T1 converges to the T, or in general you can define like here. Now look at these other options. So first option is correct. T of n, okay, any other one of this? Okay, look at the last one. We all knows, we have proved this converges to this, and g is my continuous function. Fine. Look at that. There exists a linear. So if it is a continuous, what does it means? This also converges to this, because whenever this is a continuous map, then it will be converges, but he said does not converges. So this option is cancel out. Now look over the second and the third. It means if I disprove one of them, okay, look at that, converges to the 0. Okay, Tn minus T. So what is the Tn in journal is? It's a x1, it's a x2, then xn, then xn, then xn, and so on. And T is my here. So what is my Tn minus of T? If I subtract them firstly, so you can see the first element will be 0. The first n elements are my 0, and the rest one is xn, xn plus 1, xn, xn plus 2, and so on. Is it fine? Now you can choose any of the x, because it converges for all x. So if I choose x will be my first component is my 1, so I can choose this is my 1. The nth component is my 1, and the rest components are my 0. Fine. Then what is my Tn minus 1 value? First values are my 0. 1 minus 0 is 1. 1 minus another is 1, and so on. Fine. Then what is my norm of this? Norm is again defined on my infinity norm. So what is the supremum norm? What is the supremum of this value? Supremum of this value will be my 1. So you can see Tn converges to the 0, but you can see it is not 0. So it means this option is again cancelled. So the only left option is C is my right answer for this problem. Now you can see it is for all x. It is for all x. How you can see proof that? I think again it's a very simple. How? You can see from the first part we prove that Tn is convergent to the here. So what does it means? It converges to the 0 as n approaches infinity. By the first part and by the third part you can see C is my right answer. Okay, look at this another one. Let R be the real normed linear space. Okay, what is the easiest way? R2. Fine. X naught, collection of all those x whose norm is 1. X naught contain the two distinct element. So let's say x and y belongs to this. What does it mean is norm of x, norm of y is my 1, and the line segment joining them. What is the line segment is? This is my line segment, joining them belongs to this. What does it mean? Norm of this value is also my 1. Then which of the following statements are my true? Your target is to find the x plus y. I can choose lambda is my half. Fine. So then this value will be x plus y divided by 2 is my here. Now if I look at this 2, this is my 1, this is my 1, satisfied. 2, 1, 1, satisfied. 2 square 4, 1 square 1, 1 square 1, which is not satisfied. So this option is cancelled. It's a 2 into 1 into 1 satisfied. Now look at the A, B. So they are dependent, dependent, independent. Clearly say if I say this x and y are my dependent, then this option is correct, this option is correct, but this is only the one right answer. So definitely this option and this option is cancelled out. Means how you can prove that they are Li? Because if they are belongs to the here, I can choose x is my 1, 0, y is my 0, 1. So clearly say norm of x is 1, norm of y is 1. It means these two elements are the part of x naught, and clearly say both are my Li to each other. Fine. So it means they are dependent. This option is cancelled, this option is cancelled. Right option is only A is my correct answer of this one. You can see how many seconds you are needed to prove this. Very simple. I request you don't forget to comment and the like on the video as well. Okay, look at this one. It's an orthonormal. U is the orthonormal set. U belongs to this. Norm of U is my 1. Such that norm of x is my 2. Then consider the set of E, the maximum possible number of the elements here. So very simple. If I choose n is my number of the elements, which property you can think about here? It is greater than of 1 by 4. Fine. So you can simply, if I use the Cauchy-Schwarz inequality, then I have to written as a square firstly. It is 1 by 16. Fine. Then I can take this summation of this. The right hand summation is my n over 16. Then now I can relate this one with the norm of this and norm of this. So this value I can return x minus u square. Then by the Cauchy-Schwarz inequality, it should be less than of norm of x square, norm of u square. That's over. Now you can substitute the value n over 16. What is the norm of x is 2, it's a 4. Norm of u is my 1. Fine. So can you find the value of the n? N is my less than equal to 64. So what is the maximum number? Maximum is my 64 is the right answer. Okay, consider the Hilbert space. U and V are here and inner product is this. You have to define it. I can start from this definition. V, because it's a square value, so I can return this number as here. Fine. So how you can open this? U with respect to U, it's a norm of U. What is the norm of U? It is not given, so let's assume that it's my A. So first number is A. This value into this, always remember U alpha times V, it should be of this. Fine. So what is the alpha complement of this? It's a e raised to power minus iota t u into v, norm of inner product of u into v, plus I can into here iota t v into u plus this into this e raised to power iota. Alpha I can take in is outside, it's a complex conjugate, and v into v, so I can assume norm of b is my b. Now that's over. I can substitute this. This is u into v is a 2 e raised to power iota t. Then if, because norm is my inner product is my symmetric, so I can return also this number is my iota t. This is my 1, so plus b. Now I can integrate this 0 to 2 pi. I can return this value into e raised to power iota t. So what is the answer of this? Firstly, I can multiply this. So a e raised to power iota t from 0 to 2 pi plus if I multiply this by, it's a cancel out, so integration of the 2 will be 2 pi minus 0 plus integration of this 2 will be outside, e raised to power 2 iota t divided by 2 iota from 0 to 2 pi plus b is a constant value, e raised to power iota t over iota 0 to 2 pi. So clearly say this value will be my 0. Why? You can see it value is my e raised to power 0 1, e raised to power 2 pi iota is my 1, 1 minus 1 0. This value is again 0. This value will be e raised to power 4 pi iota minus 1. Again this is my 0. So the answer is 4 pi. And if you divide it by 2 pi, answer is 2. Look at this another one. E of n is the orthonormal. Norm of E is my 1. T h is defined like here, Tn is defined like here, then again Tn minus of T. He said for all n. Firstly I can assume n is my 1. Then it's my E1 only. Then what is my T of x? T of x is summation, n is 1 only, so it's a 1. It's my x E1 E1. Then what is there for each n? I can assume n is my 1, so Tn will be, n is my 1, so it is my 1 x E1 E1. So both are same. So what does it mean? Tn minus T x, it will be 0. So it means norm of Tn minus T will be 0. So first option will be satisfied. Fine. But if you think about that, why I can take an n is 1, why not in journal? So it means my option will be, this is the right answer. It is not approaches 0, it's a cancel out. Again from here, because Tn minus T should be 0, it is not option, and lie here. Okay, how I can prove in journal? How I can prove in journal? So look at that. If I found this value, can you think about this? It is from 1 to n. It is from n to infinity. So what is the term? First n terms of this will be cancelled out. The remaining term is from here. That means it will be from n plus 1 to infinity. Fine. X comma En of En. Is it fine? That's the only term. Now you can define the norm Tn minus of T. Which norm is it given that? No. So I can take an, okay fine. So which norm is there? It's a Hilbert space. We all know L2 is also the Hilbert space. The only norm which is in the LP is the L2. So what is the L2 is? I can return this norm of square. It's a j square x minus En square, and mode of En is 1 because it's orthogonal. So this number is, this is my L2. So what is this value? It can be written is less than or equal to, by the Cauchy-Schwarz inequality, it is less than of norm of x square, norm of this value. Fine. Now if I take the square root of this, because this summation is start from the j and it is independent of j, so it can be written as this value is my 1 by the orthogonal property. So this number is 1 over j square of half. Clear? So what is the meaning of that? Tn minus T, what is this value is? N plus 1 to infinity. So clearly say when n approaches infinity, this is my convergent series. Fine. And once is a convergent, so this value will goes to the 0. So once this is 0, so again the first option is correct because it's a non-zero, second cancel, last one is again non-zero, it's a cancel out. Now how you can say that whether it is Tn is satisfied, whether it's a bounded or unbounded? How you can prove that it's a bounded or unbounded? Again, a very simple. I can clear this. Fine. So it means I can start from this value. Can I return this value? Okay. Again, I can return this number is x. This is my x. What is the remaining part is ej. Fine, because this is my summation, I can open this is ej over j, so this is nothing but my this value. So what is the norm of this? Because it is my 1, so what does it mean? This is my bounded. So once this is a bounded, so this option is cancelled out. The only option correct is my A is the right answer. So this is the way you can solve each of the question related to this norm linear space in a very simple manner. I again request you can simply like and comment on the video as well. We will see the next lecture on the Hilbert space again from this GATE examination. Till then, you can simply like, share and comment on videos. Best of luck students. Happy luck.